So today we're going to look at additional methods of factoring. And these are kind of cool. This is really where math becomes like a game for me. And I really like it. In the past I've called the type of factoring we're going to do today like reverse FOIL. Do you guys remember when we took things like this and we multiplied them, and I said a mnemonic that you could use for multiplying would be FOIL, where you multiply your first terms, you multiply your outside terms, you multiply your inside terms, and you multiply your last terms. Okay, so what we would get was 2x squared minus 9x minus 5. Okay? So we're going to kind of think in reverse of this today. And the first kind we're going to look at does not have, well, it has a leading coefficient of 1. So it's an understood 1. There is a coefficient there. It's an understood 1. And these are the types of problems we're going to start with. So, number 1. It is the trinomial y squared minus 3y minus 4. And from yesterday, you might go, ooh, it's a perfect square and a perfect square. But this is a negative 4. Is there any way I could square something and get a negative 4? No. So we know it's not a perfect square trinomial. So we're kind of think in reverse here. I know I've multiplied two binomials. And to get this first term right here, what do you think has to go here and here? What can I multiply? Y and y. Because y times y is y squared. Now this last term, guys, do you see this last term, this negative 5, came from multiplying the last ones. So when I look at this last term, I know that this and this, these two as a product should give me negative 4, shouldn't it? Okay, so let's think of our factors of negative 4. It's going to be 2 and negative 2, or negative 2 and 2, 4 and negative 1, or 4 and negative 4 and positive 1. These are my possibilities. Now, let's look at this middle term right here. Do you see that the middle term came from doing the sum of these products? So when we look at this middle term, we know this last term was we're asking ourselves, what can we multiply to get this? But this middle term came from a sum. So it's what can I multiply to get negative 4 that I can add to get negative 3. Multiply negative 4, add negative 3. What is it? It's going to be negative 4 and positive 1. Because I can multiply those to get the negative 4, and I can add them to get the negative 3. Let me show you why this works. So y times y is y squared. 1 times y is 1y. Negative 4 times y is negative 4y. And negative 4 times 1 is negative 4. So do you see these two? I add to get that middle. And it works, doesn't it? When I multiply this back, it gives me this. This, woo, that was supposed to be a box, is completely factored form. Alright, I have another example. We have 4 examples to do, and then I'm going to answer questions. Okay, example 2. So we just saw that when we do not have a leading coefficient, when the leading coefficient is the understood 1, what we're doing is we're asking ourselves, okay, what can I multiply to get negative 24 that I can add to get negative 2? So you have to think about your factors of 24. You're not writing these down, but in your head you're going, okay, 1 and 24 2 and 12, 3 and 8, 4 and 6. Well, I know they have to be opposite signs because this is negative. I'm multiplying to get a negative. So what do you guys think?
4 and 6. 4.
Okay. So which one's positive and which one's negative? 4 and 6 are correct. 4 is positive, 6 is negative. Now, some of you said negative 6 and positive 4.
Is that right?
Are these any different?
No.
No. Because multiplication is commutative. The order in which we multiply these binomials doesn't matter. Now the signs that go in front of the numbers, that matters. I can't switch up the signs and think I'm right. But I can change the order of my binomials. Because if I multiplied both of these back, either way, we're getting what we started with. So you can write it in either form. Okay, let's look at another example. X squared minus 7x plus 12. So you're asking yourself, what can I multiply to get a positive 12 that I can add to get a negative 7? Well, I'm multiplying to get a positive and adding to get a negative. So both of these numbers must be what? Negative. What are they, guys?
4 and 3.
Negative 4 and negative 3. X minus 4 and x minus 3. And if you ever need to, you can do a quick mental check. I wouldn't write it down, but x times x, x squared, negative 3x and positive 4x makes a negative 7x and positive 12. Yep, it checks. Okay, now number 4 was the problem I gave you yesterday. I said, this one looks like a perfect square trinomial. This is a perfect square, and this is a perfect square. But if I doubled that product, I didn't get 10, did I? So let's see if we can factor it today. What can I multiply to get positive 16 that I can add to get a positive 10?
8 and 2.
8 and 2. M plus 8, M plus 2. Or the reverse of that, M plus 2 times M plus 8. Okay, so now I'm going to give you 4 to try. And it's interesting. Look what I chose as my last term. 30, 30, 30, 30. But they're all different. So these are your U-tries. And if you had questions during the teaching, this is where you ask them. Okay. Otherwise, you're working on this. If you have questions while you're working on this, you can ask.
Why does it matter the order? Like, with these elements,
Okay. So we're multiplying to get negative 24, and you're adding to get negative 2. So the big number has to be. Okay. All right. As you're working on these,
But we have to do something like that.
oh, okay. So you
Yeah.
just flip the numbers, yeah. That's right. Alright, what are our factors of 30? 1 and 30, 2 and 15, 3 and 10, or 5 and 6. So this is what we're going to look at as we look at all these different 30s. And then we have to think about our signs. So on the first one, we're multiplying to get a negative, adding to get a negative. So they have to be different signs. And the bigger one needs to be negative. So, did you get x plus 2 times x minus 15?
Yes.
Okay, the second one, we're multiplying to get a positive, but adding to get a negative. So they must both be negative. X minus 10 and x minus 3. The next one, we're multiplying to get a positive, adding to get a negative, so they'd both be negative again. X minus 1, x minus 30. We're multiplying to get a positive, adding to get a positive, so they're going to be same signs. X plus 5 and x plus 6. Okay, you like that? All right. Now, it is too easy, so let's take it up just a notch.
I knew there was something else.
Not a lot of notches, but just a notch. Okay, so this is when it really becomes like a cool math puzzle. This is when we've hit Sudoku level. Alright? That, makes it more fun. Alright, so now we're adding a leading coefficient that is greater than 1. Or a leading coefficient that is not 1, really. How would we factor? Well, when we think about multiplying them, we know that when we multiply this times this, it gives us the first term, doesn't it?
Yes.
Okay. What is the only way to get 5x squared? 5 is prime. So it's 5 and 1. So this has to be 5x and 1x.
Oh, that's not bad.
So now I have to do a little finagling. Luckily with this one, there's only one way to get 2 also. 2 and 1. And I know that because I'm multiplying to get a positive and adding to get a positive, both of these must be positive. So this it's kind of like a puzzle, but it's an easy puzzle.
Oh, and then the 2.
All right. So now what you're trying to do is figure out how do I place this 2 and this 1 so that when I do the sum of these products from the outer and the inner, it totals to 11. Okay, what goes here?
2.
2. What goes here? 1, because 10x plus 1x is 11x. Okay, so this method is called trial and error. Okay? Because we're just kind of, the first one we get to pick and establish the way it goes. But these second two we're going to kind of have to play with a little bit. All right. So what is the only way to get 3x squared? 3 and 1. So 3x and 1x. Now, we're not going to have to worry too much because what's the only way to get 1?
1 times.
1 and 1. And we're multiplying to get a positive, but we're adding to get a negative. So what kind of ones are those?
Negative 1.
Negative 1 and negative 1. Because a negative times a negative is a positive, and a negative plus a negative is a negative. Let's check. Outer, negative 3x. Inner, negative 1x. Did that give us the negative 4?
It did.
Yes. Okay. Now, you try. This one, you might have to play with it a little bit.
Wait. too easy for you.
Good. All right, so you got 3x and x, and we know this has to be 2 and 1. But we got a negative here. So we don't know if the 2 is negative or if the 1 is negative.
One's negative.
All right. Actually, the 1 is positive and the 2 is negative. Because this will give me a positive 3x minus 2x leaves me 1x. And you may have to play with it. You may have to put it in and check it out. Test it. You may have to erase and try again. It's trial and error. You try, you make an error. You try again until you get it right. All right. So, no, guys. Somebody else said that. I did not say that. All right. So, 2x squared plus 7x minus 15. There's only one way to get 2x. 2x and x. But there's multiple ways to get 15. 1 and 15, 3 and 5. We want to multiply to get a negative, so we know these are going to have opposite signs, and we're adding to get a positive 7. For me, it's so easy. I see, 5 goes here, that makes 10, negative 3 goes there, 10 minus 3 is 7. Done. Now, the reason it's easy for me is because when I was your age, we did probably 50 problems a night. Until we attained this skill. And we were excellent at this skill. We mastered it. Now, and we did. We knew it well. Okay, one more for you to try.
That sounds boring.
No, it's just fine. Okay. Guys, look at this one. Am I going to start with the first term on this one? No. I'm going to place the last term in. Because the first term, there's choices. It could be 1 and 8 or 2 and 4. I'm never going to start with the one that has choices. Unless they both have choices. Okay? So, I'm multiplying to get a positive and adding to get a negative. So I know it has to be negative 1 and negative 3. Because I'm multiplying to get a positive and adding to get a negative. So now, I have to figure out, how can I get a negative 10 out of this?
Right, it's a check. Well,
You could.
Oh.
Right there.
2
Right there.
x minus 1.
2 goes right there, 4 goes right there.
Minus 3.
Beautiful. That gives me negative 6 and a negative 4 makes a negative 10.
I was about there.
Negative 10.
I feel like
Don't say it.
Okay. You try. It's going to look almost the same. I'm changing it to a minus 3.
That is not.
What's that?
So it's going to take like.
It shouldn't take that long. Okay, the 1 and the 3 are the only thing we know for certain. We don't know the sign here or the sign here. And we don't know if this is 1 and 8 or if it is 2 and 4. Now, some of you innately see it. Some of you see it so fast and you go, oh, if this is 4x and I put a negative there, that makes negative 12. And then I put a positive there and a 2x there, negative 12 and positive 2 makes negative 10. And you just see it. And then others of you have to plug it in and try it. Whoops, didn't work. Plug it in again and try it. What's going to make you better?
Trying it.
Yep, practice. Alright, last one. 6x squared minus 13x minus 8.
Wait a minute, what? I don't want to ruin my winning.
This is a little more difficult because my leading coefficient and my constant, neither are prime. So we have choices for both.
Why?
Okay? So we have choices for both. 6 could be 2 and 3, or it could be 1 and 6. What do you want to start with?
Oh, so it's
1 and 6?
1 and 6.
Okay, let's start with 1 and 6. So 8 could be 1 and 8 or 2 and 4. And we know they're different signs, so if I did a 2 and a 4, that would give me 12 and 4. There's no way to make a 13 out of that. If I did 4 and 2, that would give me 24 and 2. Can I make a 13 out of that? Okay. So 1 and 6 didn't work, did it? All right, let's try 2 and 3. 2 and 3. So let's go with 1 and 8. If I did 8 here, that would give me 24 and 2. Is there any way to make a 13? But if I put an 8 here, that would give me a 16 and a 3.
Oh, yeah. So
Yeah. Which one needs to be negative? The 16 or the bigger one? Negative 16, positive 3. Done.
Wow. That was tricky.
So,
you just have to like, guess yourself.
exactly.
Yes, sir.
Exactly. All right.
I don't hear it.
All right. Your homework, once again, is out of the workbook, not out of the textbook, as your calendar says.